Good morning. I wanted to share this spreadsheet with you. This will simplify graphing on that gravity force lab that I assigned on Friday. If you've already finished it, grand, just ignore this. If you haven't, actually if you have finished it, you might find this interesting. There are some interesting things you can do with Google Sheets, and I'll try to kind of explain some of that here. So I've made 4 pages here of information. I've got your 4 graphs. If the first time through you changed mass 1, the second time through you changed mass 2, the third time through you changed the distance between the 2 masses, holding those 2 masses constant, and the 4th time you did a little manipulation of the data. Those are your 4 graphs that you should have. So anything highlighted in yellow is something you should change. So on my first graph, I took this data down. I kept mass 2 constant, changed mass 1 to be all these numbers, and then I got these numbers for my gravitational force. I want to show you the formula that's right here. This formula is, I think it simplifies entering these tiny, tiny numbers. I just type in the base number. So the number I got was 1.36044 times 10 to the negative 7th. So I can type that number in here, 1.36044 times, and then this equation here, power, open parentheses, 10 comma, negative 7, close parentheses. And that just means 10 to the negative 7th. So this number that's displaying is, whoops, undo that. This number, holy cow, undo that. This number that's displaying here is 1.36604 times, whatever it is, 1.36044 times 10 to the negative 7th. And I don't have to count zeros so intently. And then I've got this automatically updated, so the graph will change. As you type in your number, if I would change this number to be ridiculously high, you'll see my graph will change. So you can type in your numbers here, your real data values that you got, and type in your masses here, your gravitational forces here, and it should generate this graph for you. Do the same thing with graph 2. You enter your data, I'll make up a number here, and you can see that it will change the graph. So you just enter your numbers, and you'll get a nice straight graph if you do this correctly. The third one, I changed the way I entered the data, so just only enter information in the items that have that are highlighted in yellow. So here you're putting in your distances between the 2 masses. Here, just type in the base number that you got for your gravitational force. And here, type in your exponent. So this line represents 1.71752 times 10 to the negative 7th. I'm just typing in the base number. I'm typing in the exponent. And this formula will perform that calculation. So you don't have to change this column at all. Only touch the things that are in yellow, and you can see if I type in a number, it gets to be, it'll automatically update the graph. You don't have to fret about that. The last thing is your graph 4 is where you kind of straighten graph 3. Graph 3 is curved. You're going to do a little bit of algebra on this to straighten it. So once again, you can enter your distances that you got on your 3rd pass through, and you can enter your base numbers and your exponents, and then this will perform the little algebra for you. You're supposed to be down here on the x-axis is supposed to be 1 over distance squared, so this will do that calculation for you. 1 over, that's this column here squared. This is your x-axis. And then your gravitational force is just the same thing that we did on page 3 on the changing distance graph. It's your exponent, your power, your base multiplied by your exponent. So, and you should get a nice straight number. And you can see if I change a thing over here, it will definitely, well, it'll change the graph. Not dramatically, but it does. So, good luck with that. Go be awesome. If you have any questions, good luck, I guess, is the thing. I can field emails perhaps.